Hello! Alright, so the purpose of this video is to show you basically how these word problems work. Okay, so it says first what I see is Hime jumps from a cliff into the ocean. Yeah, that's my cliff. Okay, so Hime jumps from a cliff into the ocean while vacationing with some friends. Okay, her height as a function of time can be modeled by this function. So we have the equation y equals negative 5x squared plus 10x plus 25, where x is a time in seconds and y is the height in meters. Okay, so let's go ahead first. Let's kind of think what we have here. So x here is going to be represented by time. So it's not going to be distance, it's going to be time. And our y-axis here, so this is our y. Our y is going to be represented by height. Okay, height, right? So what we're trying to do is trying to figure out when will Hime hit the water. Okay, and you want to round your answer to the nearest hundredth. So this little part here where it says round your answer to the nearest hundredth. Basically what we're going to eventually have to do is we're going to have to take a square root of something. Okay, so for purposes of this video, whenever we have to take a square root of something, I want you just take that actual decimal answer. Do not worry about how we've done it with like simplest radical form, because it's a real life word problem. What we're going to do is we're going to actually try find some sort of exact value or something close enough to the exact value. But anyway, let's try to decipher what this means. Okay, so when will Hime hit the water? Okay, so let's just say that at sea level she starts at 0 meters. Let's just assume that at sea level or the ocean she'll start at 0 meters. Okay, so that is when she would actually hit the water. Okay, so that would be basically y equals 0 meters. Okay, and then what we need to do in order to solve for the time when she hits that the water, what we need to do is essentially, so we don't need the units anymore. Essentially what we need to do is we're going to go ahead and take this this value, so y equals 0, and we're plugging this in for y, as you can see there. Okay, so let's go ahead and do that. So when we go ahead and do that, we get 0 equals, so negative 5x squared plus 10x plus 25. And then if you guys see what we can do here is we can apply the lovely quadratic formula. So if we apply a lovely quadratic formula, we get a equals negative 5, b is 10, and c is 25. Alright, so let's go ahead and apply that lovely quadratic formula. So x is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. Okay, so we have x equals, so negative 10 plus or minus square root of, we get 10 squared. 10 times 10 is going to be a lovely 100. Alright, so we have a negative times negative here becomes positive. We have 4 times 5 is 20. 20 times 25, I believe, is 500. Okay, next we're going to divide by 2 times negative 5, which is negative 10. Okay, now what I see is we can simplify what's in the square root here. So we have x equals, so negative 10 plus or minus square root of, so we have 100 plus 500, so that's going to be 600. And then we're going to divide this by negative 10. Alright, so next what we need to do is we need to take the square root of 600. Alright, so let's go ahead and take the square root of 600. So what we can do is we can put square root, so however you want to do it, you can take a square root on your calculator, or you can go ahead and use a calculator or graphing calculator if you have one, whatever you prefer. But if I take the square root of 600 here, so this can be 24.495. Okay, so 24.495. I'm just going to keep it to the thousandths place, just in case anything weird happens. So we have negative 10 plus or minus, and then we have 24.495, and we're dividing it by negative 10. Okay, so what we have here is we're going to have two possible solutions that come out of this. Okay, so we have x equals, so we have negative 10 plus 24.495 divided by negative 10, or we get x equals, so negative 10 minus 24.495 divided by negative 10. Okay, so if we were to simplify this, so negative 10 plus 24.495 is going to be 14.495, and if you divide it by negative 10, do this correctly. So it should be negative 1.45. So do that correctly, and that's what that should be. Okay, if you do negative 10 minus 24.495, that should be negative 34.495. Divide this by negative 10. I believe if you do this correctly, this should be something like 3.45. Okay, so this next part is where it gets a little bit interesting. So this part here is this and this. All right, so let's go ahead and analyze this parabola that we have. So what we have is, let's go ahead and actually, if the parabola were something like this, kind of like what you guys are used to on the XY axis, right? So this means that basically she will hit the water at at y equals 0. So that's going to be at sea level. She's going to hit it here or here. Okay, so what we have is, this would represent the time. This is the time at negative 1.45 seconds. And this time here is represented by x equals 3.45 seconds. So you might wonder, you might be thinking, well, okay, well, when does she hit the water? Is she going to go backwards in time? Can we have a negative time? Or is time only positive? Okay, so what I can see here, basically, I see time is only positive, so we can omit this solution. And this means that basically she should hit the water in about 3.45 seconds. About 3.45 seconds. Okay, so this, if you're wondering, would be our answer. So we wouldn't take the negative, we would cross this out, and our answer would just be 3.45 seconds. 3.45 seconds. So that, as you can see here, that is when he may will hit the water. 3.45 seconds. Okay, let's go ahead, let's just do this for fun. There's another way that we could also approach this. Okay, so let's go ahead and actually graph this. So we have y equals negative 5 x squared plus 10x plus 25. And let's say we graph y equals 0. So that's a lovely line right there. If we were to just click here and here, that gives us exactly what we got earlier. So as you can see, what we got was, we got negative 1. I just rounded to the nearest hundredth. Remember, we had to round to the nearest hundredth. Okay, so what we need to do is, we have negative 1.45 as one of the solutions, and we have 3.45 as another solution. So what we did is, if you round to the nearest hundredth, as you can see here, she wouldn't be going backwards in time, but she would only be going forwards in time. So her little, when she starts here and she's jumping up, she jumps actually really high. If she's jumping like 5, it looks like 5 meters up. But anyway, so she's jumping really high, and afterwards she comes back down. Yeah, I probably should have chose better numbers, but generally that's what you would do for this. Okay, so all right, that's basically it. Okay, I'm gonna continue this in the next video. I'll see you later. Okay, bye. Hello. All right, so let's continue. Okay, so part B. Let's say we want to find the maximum height that he may reaches when she goes ahead and jumps. So as you can see here, right, this is what we started with in the first video, right? So what we're trying to do is, we're trying to figure out the maximum height. So what is the highest point that she reaches before she comes down? Okay, so let's go ahead and try to figure it out. So what we can do is, we can apply some of the things that we know. So if you guys remember, there's a lovely thing called completing the square. So what I see what we can do is, we have y equals, I can factor out negative 5 if I put parentheses here. So negative 5 here, x squared, and then minus 2x, and then plus 25. Okay, next what I see here is, if I were to go ahead and put a blanks, we have y plus blank equals negative 5 times x squared minus 2x plus a blank plus 25. Okay, so what we do is, we need to calculate b divided by 2 squared, but first what we need is this. So we need a negative 2 here. So we need to calculate b divided by 2 squared, which is going to be negative 1 squared, and that's 1. So 1 goes here. On the other side is negative 5 times 1, so it's going to be negative 5. So we have y minus 5 equals negative 5, and if you guys remember how to factor this, this is basically x minus 1 times x minus 1, and then plus 25. We can group these together, so y minus 5 equals negative 5 times x minus 1 squared plus 25. Now, what we want to do is, in order to find the maximum height, we can add 5 to both sides here. When we add 5 to both sides, we cancel. So y equals negative 5 times x minus 1 squared, and then plus 30. So, if you guys remember how to determine the maximum height, or in other words, a maximum of a parabola, we just look at the last number. So, basically, our y value, the maximum height, is going to be 30 meters. So, y equals 30 meters. Yep. And as you can see, that's exactly what we got here. If I were to click that there, 1 comma 30, so that's basically the y value is going to be 30. Okay, so that one's kind of neat. That one shows you how that one works. I want to also show you something interesting. Let me show you another way that you could solve this. It's actually a little formula. Okay, so yeah, so I'm just gonna go ahead and just erase some of these things here that you see. Okay, let me show you a different way that you could go about this. So I can kind of see some of you like, well, I don't know how to complete the square. It's like, all right, fine. Like, okay, so again, what we started with was y equals, so negative 5x squared plus 10x plus 25. Now, another way you could find the maximum height is this formula. There's a little formula that says like if you want to find the maximum or minimum of a parabola, basically you just calculate x equals negative b divided by 2a. So this one is really easy. You just need to identify what a and b are. You don't even need c actually. So a is negative 5, b is 10. So what we can do is just plug it in. So x equals, so that's going to be negative times 10 divided by 2 times negative 5. So we get negative 10 divided by negative 10. So negative 10 divided by 10, negative 10 is going to be positive 1. As you can see here, that's exactly what we have. So x is 1. X is 1. Isn't that so cool? So in order to find our y, so you might be thinking, well, how do we get our y? Simple. All you do is just plug it back in. You can plug it back into here and here. And that's how you can find your y value. So you do y equals, so negative 5 times 1 squared plus 10 times 1 plus 25. So you get y equals, so negative 5, so negative 1, 1 times 1 is going to be 1, so negative 5 times 1 is going to be negative 5. So plus 10 times 1 is going to be 10, plus 25. And then you have y equals, so this is going to be negative 5 plus 10 is going to be 5. 5 plus 25 is going to be 30. That's our y coordinate. So that means our maximum, our actual coordinates are 1 comma 30. And we still know that y equals 30 meters. That would be the maximum height that he may reach as she jumps. So yeah, kind of cool what you can do with that. So generally, this is what you would do if I asked you to solve like for a maximum height, and then let's say completing the square is like completely like messy. Like you could actually solve for the maximum height by using this little shortcut here, this x equals negative b over 2a. So whatever you decide to do. Yeah. All right. So that's basically it for that one. Okay. Bye. Hello. All right. Second problem. Okay. So let's say Kylene throws a ball. So this is Kylene. She's throwing a ball upward. That can be modeled by this equation. So y equals negative 16x squared plus 5x plus 15, where x is the time in seconds and y is the height in feet. So what we have, just kind of just looking at these things, x is going to be time in seconds, and then as you go up here, right, so this is going to be y is going to be the height in feet. Okay, so at the same time, Shireen, so this is Shireen here, she's going to throw a rock upward that can be modeled by this equation that you can see here. Okay, so what time will the ball and the rock reach the same height? So you're trying to figure out where they reach the same height. Okay, so round your answer to the nearest hundredth. Okay, so what we can do here is, well, in order to figure out where they intersect, so that's kind of what I was showing you guys earlier. So usually, like in unit 2, what we've done was we've compared two lines together, right? And then we could set them equal to each other and solve for x. Now what we have is we have two parabolas. So what we can do is, you see these y's here, basically we can, they're the same. So what we can do is we can just put this equation here. So we have this equation. We're going to drop it right here. Okay, so that's exactly what we're going to do. Okay, so we have negative 16x squared plus 5x plus 15, and then this equals negative 15x squared plus 20x plus 2. Okay, so next, what I see we want to do is we want to get all the terms on one side. Eventually, we want to try this quadratic formula. So what I see is we could add 16x squared, and we can subtract 5x, and we can subtract 15. It's going to add 16x squared, we're going to subtract 5x, and subtract 15. So our goal is we want to get 0 on one side. So we got 0 on one side. So we get negative 15x squared plus 16x squared is x squared. 20x minus 5x is going to be positive 15x. 2 minus 15 is going to be negative 13. Alright, so now we can apply that lovely quadratic formula. I'm going to write on the side here just to make some room for myself. A is 1, B is 15, C is negative 13. Alright, now let's plug in this bad boy. So x equals negative b plus or minus square root of b squared minus 4ac. Divide by 2a is what Mr. Chang sings. These are a few of my favorite things. Okay, 15 squared. 15 times 15 is going to be 225. Two negatives become positive. 4 times 1 is 4. 4 times 13 is 52. We're going to divide this by 2 times 1, so that's 2. Okay, so let's go ahead and simplify this even further. So what I see what we can do is this is going to be negative 15 plus or minus square root of, so 225 plus 52 is going to be 277, I think. All right, and then we're going to divide this by 2. Okay, so now what we need to do, in order to round this to the nearest hundredth, what we need to do is we need to use our lovely calculator. Okay, so our lovely calculator. So what we're going to do is we need to find the square root of 277. Square root of 277 is going to be 16.643. Okay, so I'm just going to put this here. So this is basically negative 15 plus or minus 16.64. We'll just doesn't really matter. We'll just put 16.64, and then we're going to divide this by 2. Okay, so what we have here, as you can see, is we have two possible solutions that can come out of this. Okay, so I'm just going to write this up here because I'm running out of room. Okay, so we have x equals. Okay, so we have negative 15 plus 16.64 divided by 2. Do this correctly. So then what we have is negative 15 plus 16.64 is going to be 1.64. Divide that by 2, and that's going to be about 0.82. Okay, then we have our other x. So x equals, so negative 15 minus 16.64 divided by 2. Okay, so if you do negative 15 minus 16.64, this is going to be negative 31.64. Divide that by 2. Do that correctly. You're going to get negative 15.82. Okay, so as you can see here, we have two possible x values. We have 0.82 and we have negative 15.82. So what this means in context is basically there's two possible solutions that come out of this. So if we were to draw this, all the way down and maybe draw this one all the way down, this means that somewhere they're going to intersect at two x values. So we have x where it is 0.82 seconds, and we have another x way down, maybe somewhere past the way in the negatives. We have somewhere here, I don't know exactly where, but this is going to be our other x value, and that's going to be negative 15.82 seconds. So you might be wondering, it's like, well, okay, well, which answer might this be? Can we travel in time? Can we have negative seconds? Or is this going to be represented by a positive value? So actually, so if you guys think about it, we can't have negative seconds. So since we can't have negative seconds, it has to be this one, which makes sense. If you were to throw a ball and you throw a little pebble, and it would take about maybe less, depending how far you throw it, but maybe a little less than a second to go ahead and see where the heights will actually meet up. But anyway, that seems like what it would be. So that looks like our answer. So we would omit this, and we take this to be true. So since we're taking this to be true, this one is good. So this means our answer. So at what time will the ball and the rock reach the same height? That's going to be at 0.82 seconds. So at 0.82 seconds. We have rounded our answer to the nearest hundredth, and we have answered the question. Okay. All right. So that one's kind of neat. All right. I'll show you one more example. Okay. Bye. Hello. All right. So I really like this problem. Okay. So let's say we have Jacob. Jacob shoots a basketball from a certain spot on the basketball court. Okay. So the ball is modeled by the equation, this equation here. So x is going, again, so x is going to be time in seconds, and y is our height in feet. So let's go ahead and draw that here. So x represents time here. And what we have here is y is going to represent height. So height. Okay. So assuming the height of the basketball rim is 10 feet, which a regulation basketball rim net sits at 10 feet. At what time will the ball go through the net? Okay, so you're trying to figure out the time that the ball goes through the net, and we're going to round our answer to the nearest hundredth. Okay, so what I see is we're given a formula. So this is modeled by some sort of equation. Right, so we have y equals negative 16x squared plus 25x plus 3. What we know is y is the height in feet. So what this means is we're trying to figure out where the ball will pass through the net. So it looks like the ball will pass through the net at 10 when the height, or in other words, y is 10 feet. So what we're doing is we're taking this value 10 and we're plugging it into here. Okay? So what we have is we have 10 equals, so negative 16x squared plus 25x plus 3. Okay, what I see what we can do is we want to try get all terms on one side, so we're going to subtract 10 on both sides. So we subtract 10 on both sides, this cancels, we get 0 equals negative 16x squared plus 25x, and then 3 minus 10 is going to be negative 7. Alright, so now that we've gotten it in this form, we can use the lovely quadratic formula. So what I see is a is negative 16, b is 25, and c is negative 7. So let's go ahead and try to see if we can solve this. So x is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. Alright, so let's go ahead and try to see what we get. I'm going to just put this over here. So x equals, so we have negative 25 plus or minus square root of, so 25 squared, so 25 times 25 is 625. Two negatives here become positive. So what we have is we're doing 4 times 16. So 4 times 16 is 64. Okay, 64 times 7. So we get 8, carry the 2, and that's going to be 448. Okay, so again, what we have two positive here. So we're going to subtract 448. Okay, so that's a little math there. I'm just going to go ahead and erase it. So we're going to subtract 448. Okay, so next what we're going to do is we're going to divide by 2a. 2 times negative 16 is negative 32. Okay, so next what we're going to do is we're going to go ahead and simplify this. So we have negative 25 plus or minus square root of. So 625 minus 448 is going to be 177. And we're going to divide that by negative 32. Alright, so now we need our handy dandy calculator to find square root of 177. So square root of 177. So this is square root of 177 is going to be 13.3. Looks like 13.3. Alright, so let's go ahead and simplify this. So they have 25 plus or minus 13.3. We'll say 30. And then we divide this by negative 32. Okay, so I'm running out of room. I just need to go ahead and put the x's somewhere. So we have x equals to negative 25 plus 13.30, and we're dividing that by negative 32. Okay, so do this correctly. So negative 25 plus 13.30 divided by negative 32. Do this correctly. I think this is going to be 0.37. Okay, now we gotta do the other one. So x equals, so negative 25 minus 13.30 we're dividing this by -32. Do this correctly, and it should be something like 1.20. Okay, so this looks a little bit interesting. Oh, so now we have two x values that are positive. So what this means, as you can see here, so the ball, as Jacob shoots it, so the ball is coming up, so at this height, it reaches 10 feet. And when it comes back down, it also hits 10 feet. So what this means is, well, if you're considering time, this would be 0.37 seconds. And at this final time, this would be 1.20 seconds. So you're trying to figure out at what time will the ball go through the net. So as he shoots the ball up, it passes 10 feet at 0.37 seconds. But then when it actually comes down into the net, it's going to be this one. So what that means is that we would omit this one, and we take this one to be true. Okay, so what that means is basically if you're finding out at what time will the ball go through the net, and that is going to be at 1.20 seconds. All right, and that is basically it. Okay, so those are your 4 word problems. Please let me know if you have any questions. Okay, bye.